All right, so when you have a total mechanical energy situation, like so, a roller coaster, right? All of our energy at the top, point A, is potential energy. So ME is our total mechanical energy. I have potential and 0 kinetic at the top. So that means the total mechanical energy is equal to the potential energy. So if I want to find the total mechanical energy, I use the equation for potential energy. This is gravitational potential energy, by the way. So at point A, PE equals m times the acceleration due to gravity times the change in height, or our displacement. The mass of the object is 10 kilograms. G is always 10 meters per second squared.
My room is not late every day. I'm not late every day. You come to my room.
So at point A, our delta Y is 5 meters. So our total energy is equal to our potential energy. Okay, at point A, our total mechanical energy and our potential energy is 500 joules. We already said that our kinetic energy is 0. Okay, that should make sense. Remember that the total mechanical energy is the sum of both the kinetic and the potential. 0 plus 500 is 500. Once you get the total energy, we say, okay, is there friction in the system? No, there is no friction. So that means all of our mechanical energy is going to be conserved throughout the entire roller coaster. So our total does not change. Our total will be 500 the entire time. And that's important because that's going to help us find the missing kinetic energy at each point. So now all I need to do is find the potential at points B, C, and D. At B, you're multiplying 10 times 10 times the height at B, which is 1 meter. So you have 100 joules of potential energy. Since we know the sum of kinetic and potential has to be 500, we know that the kinetic has to be 400. In order to find the speed at B, I need to use an equation that has V in it. The only equation that has V in it is the kinetic energy equation. So once I have the kinetic, I can find the speed. Okay, with a little bit of algebra, we can find the speed which is 8.9, rounded to the 10th place. Okay. Go throughout this process to solve for the rest of the missing variables. Notice at D, all of our energy is in kinetic. When you find the speed, you're using the same as the total energy. Once you get to number 3, how much work is done to the force of weights to raise the car to point A? we know that the work done is the same as the potential energy, just negative. So to find the work, you find the potential energy at A, which we already did, and it's 500, and you make it negative. In order to gain potential, you have to do work against gravity. That's why it's negative.